Hello everyone. So in this video we will be discussing second law of motion. In my previous video I had talked about momentum and I had given you an idea about what is momentum. In this video we will be studying the second law and relating momentum with force. So in short, in this video you will be understanding the second law and then the significance of second law, that it helps you in measuring the force. So we are going to derive an expression for force. So first let us state what is second law and then understand the derivation step by step. Whenever we say laws of motion, it automatically means the Newton's laws of motion. So the second law states that the rate of change of momentum of a body is directly proportional to the external force and takes place in the direction of force. Now in this, something very interesting, and that is this term external. Now you may get confused thinking that why do we write external over here? It's very important because when we are talking about the change of momentum of a body, you have to apply a force outside the body, not from inside. The best example of this is to think about yourself sitting in a bus. If you're sitting in the bus and you're trying to push the bus from inside, you'll never be able to make it move. But if you all come outside the bus and push the bus starts moving. Because once you are inside the bus and you are pushing, you are applying a force that is called internal force. But when you all come out, step out, and then apply the force, then the force is being applied from outside the body and it's called an external force. So, this is the force which will bring a change in the state of rest or motion of the body, not the force when it is applied internally. So, the statement says that the rate of change of momentum of a body is directly proportional to the external force and takes place in the direction of force, which means if I apply a force, the momentum of the body is going to change and the change will be in the direction of applied force only. So let us take an example. Suppose there is an object, a car or a cart, whatever. It is moving with a velocity u. Now a force is applied on this in this situation, and now it starts moving with a velocity v. So that means its velocity changes to v. Mass obviously remains the same. So the initial momentum of the body, let it be pi or p1, so it will be mu. Final momentum after the application of force, let's denote it with p2 and it will be mv. Let t be the time in which the force is applied. So using this we can find out the change in momentum. Change in momentum will be P2 minus P1, final minus initial. So it will be MV minus MU. And from here, you can also now write down the expression for rate of change. Now, whenever we say rate, rate means you have to divide that quantity or the change with time. That is the meaning of rate. So rate of change of momentum will be mv minus mu divided by t. It's very simple. Now, by the second law, it says that the rate of change of momentum is directly proportional to the applied force. So, here my rate of change of momentum is m v minus u by t, and it is directly proportional to applied force. So, you can also write it as F proportional to m v minus u by t. For those of you who don't understand the meaning of proportional, these are called direct and inverse variations. So when we use a proportionality sign, it means that the force is going to be varying with the momentum and the time of the object. So it changes into mass and change of velocity. This is a symbol for the proportionality. So this I can further write as m into a, because we've already done in equations of motion that v minus u by t is equal to the acceleration in the body. The proportionality sign needs to be removed. Whenever we do that, we remove it with and replace it with a constant k. Now, generally in physics, in a lot of expressions, you'll find that the value of k is either 1 or some fixed value. So it's a constant. So k, you can also call it the proportionality constant. Proportionality constant means on removal of proportionality sign, when you replace it with equality, equal sign, then you have to replace it with a constant k. This shows the pattern of variation of force with mass and acceleration. It's not necessary that the k value is 1. It could be 2, 3, 4, whatever. I'm not giving it a straightforward value, but I'm just telling you that it can have a value. So in this case, what happens is we say that if mass is equal to 1 kg and a is equal to 1 meter per second square, that means unit mass, unit acceleration, then F is also 1 unit. I'm not giving you the unit right now, just wait a while. So when we do that, it means 1 is equal to k 1 into 1, which automatically means that k is equal to 1. So in this expression, the value of k is equal to 1 by the choice of units. So therefore, F is equal to m into a. That's the expression for force. Now you can calculate the force that is being applied on a object. Now we have to now define the unit of force. So 1 kilogram into 1 meter per second square, that is the acceleration, is defined as 1 Newton, right? You can also write the unit of force as kilogram meter per second square, but the Newton has been honored by giving the force his being with using his name as a unit. So that's a huge honor for him and for all of us, because he's the one who's given us so much heavy contribution in physics. So 1 Newton is defined as 1 kilogram into 1 meter per second square. So therefore, the unit of force is Newton, denoted by capital N. So how to define 1 unit now? 1 Newton of force. If on applying 1 Newton force, an object of mass 1 kg is accelerated by, you can see, on applying 1 Newton of force, an object of mass 1 kg is accelerated by 1 meter per second square. Or other ways, like if you apply, if an object of 1 kg mass gets accelerated by 1 meter per second square, then the applied force is 1 Newton. Now, I always ask my students the obvious question that how much is 1 Newton force? Because for them, for you, for everybody to visualize how much is 1 Newton is very essential. So, right now, since we are not into gravitation, so we will discuss it in much details later in the gravitation lesson. But just for you to understand, to feel the 1 Newton of force is that if we place 100-gram mass on our palm, then the force exerted on the palm is 1 Newton. So let's keep the suspense, and when we discuss the gravitation chapter, you will be able to understand it much better. So this as an example is very simple to understand. Just take 100-gram mass from any vegetable vendor, put it on your hand, and then see. The force will be 1 Newton on your palm. So thank you. Happy learning.